It's the fifth talk of the day already. I can't believe how fast it's going. If you're just joining the technical track, I'm John Knowles, CTO at JH, and your host for the day. So far, we've heard about performance analysis and front-end performance, but now it's time to lift the bonnet, or the hood for our American audience, on Magento caching. If you would all like to welcome our next speaker, Patrick McLain, who is going to be talking about fast cache with Magento. Welcome, Patrick.
Hey, thanks, John. Thank you, everybody, for joining, and I really appreciate the opportunity to continue to meet virtually, even though we can't all be together. So wanted to take a moment to talk about making fast cache with Magento, which is a terrible pun, I will admit, but really a lot of us have heard various speakers at different conferences talk about the cache layers within Magento, and wanted to really dig in pretty deep into the DI cache and really what happens in the internals of how Magento optimizes the DI compilation process to take advantage of op cache. So to give you just a little background on myself, I'm currently the lead Magento engineer for Reynolds American, which is a subsidiary of British Tobacco. I'm an active contributor to the Magento open source project, as well as on the maintainer group. Have not been as active in the last 6 months as I have been over probably the last 2 years, just due to some work commitments, but hoping to ramp that back up towards the end of the last half of this year. I'm an open source fanatic, so if it's anything that touches the Magento stack, I love digging into it. The open source projects, contributing, really any bug fixes that we can increase performance, reduce bugs with the overall Magento open source application. So what we'll cover today is take a very 50,000-foot overview of what is op cache. So it's something that most of us see when we do PHP and we're checking our version and maybe seeing what is Xdebug on locally. And then there's usually a line that says op cache with some version information. So we'll take a look at what that actually is. And then we'll also look at what the performance benefits of having op cache enabled versus disabled, and how Magento actively utilizes op cache for performance. And then we'll wrap up taking a dive into what are some potential future optimizations. So I will preface this with this is a high-level intellectual. It's more of a thought experiment. And the implications of what we see today are mostly at the platform level. So this is about Magento internals. There is not a lot of practical application that can be applied to an individual site or an individual storefront. This is about the application that we all use and most of us are deploying to transact with our consumers. So digging into what is op cache, really, I lifted this directly from the PHP manual. So it's really improving the performance of PHP by taking the PHP scripts that the language is loading at runtime, compiling them down to bytecode and storing them into memory. So really what this does is it takes your application code, it compiles it down, stores it in memory, and then the application for each subsequent request, the language isn't going down at runtime, reading the files from the file system, compiling them down to bytecode for execution. So in when we're running on our production servers, most all of us have this enabled. It's probably enabled on your local environments by default, with probably some different configurations than what you have in production, hopefully. And just to take a quick look at what happens with op cache being enabled, just for a standard page load. And this is not scientific by any stretch of the means. there's a lot of research that's been done, very good benchmarking by people much smarter than myself. Uh, these are really results from my local MacBook Pro, so they're almost worthless. But you can see the bottom, we have op cache is completely disabled. We're loading a simple product page. Our response time is about 3.5 seconds, and it consumes about 110 megabytes of RAM. We enable op cache. We warn the op cache by loading the application at least once. We can see that response time drops to 1.5 seconds, and we're only consuming 22, 23 megabytes of RAM. So significant reduction in response time, as well as memory consumption. And again, this is because the language, the runtime isn't going back to the file system. It's not trying to reparse the actual application code. It's already loaded. It's already stored in memory. Let's see, that is, we're down 55% in our response time, as well as 79% in memory. So how does Magento actually leverage op cache? So we saw in the last, when we're looking at the performance of just loading a product page, there's a performance benefit simply by having it enabled and configuring it to not revalidate the files every time it loads. But Magento actually uses op cache to its advantage when you're in production mode. How it does that, yeah, I messed up the slides here. So what actually happens is when you run setup di compile, you see it takes a couple minutes, and it's probably happening on a build server. The output of setup di compile is in your generated folder, and there's 2 directories, and one you only have after you run this command. So if you're in developer mode, you won't see this directory, but it's generated metadata. So if you look inside generated metadata, you'll find that handful, probably 6 or 7 PHP files, and inside of those are arrays. And inside of those PHP files are the actual immutable configuration data that's read from the file system when Magento goes through and generates all that information. So when it's doing the hard work of reading all the DIXML files, finding the plugins, finding preferences, building out the configuration for the service container, the object manager. And all of that goes into these metadata files. And the reason for that is to leverage op cache when you're running in production. And that's because when you're running locally, what happens is that as the page loads and you're in developer mode, it pushes that information into Redis or whatever your backend cache engine is. If it's file system, it'll actually wind up in var cache, and you can see it there. But once you have it in generated metadata, as the application bootstraps, it doesn't have to go back out to Redis. The configuration of the object manager is already in the file system, and op cache, after it's loaded the files once, or these configuration files once, the configuration is already in memory and compiled down to bytecode. So this goes back to the dark path that was taken to really dig in and understand how this works. Most of us don't ever want to go this deep inside of the framework because it's not pretty, and it's not something that we're doing throughout the normal process of building a storefront for a client, or for our business users if we're working internally. Browsing GitHub issues late at night, like most of us who are addicted to open source contribution might do, I've stumbled across this issue with a very interesting title. It caught my eye. The Interception Cache compilation is useless. So first I'm looking at it, I was like, well, I don't really understand what the interception cache compilation does. I've run setup DI compile, I see the different steps, and I know that's one of those steps, but that's all I know. And so I'm reading through the issue, and it shows you that you run this command. You see that it's generating the interception cache, um, but then the interception cache is written to the configuration cache, which actually winds up in the backend cache. So if you're running your build process on a remote server, which is pretty standard practice, uh, it's not going to be connected to the production configuration cache. And also, I don't really understand what the interception cache was. And would it ever change? I'm assuming it wouldn't, just based on the fact that it's generated when I run setup DI compile. And really, the description of the issue goes into a bit more detail and explains that there's no point if it's writing to Redis or the backend cache to generate it at build time. And that rebuilding it was very CPU intensive. And it also put a lot of strain on the file system. So there were some benchmarks in the ticket that after you flushed your cache or cleared the configuration cache, 70% of the first page load time was spent rebuilding this interception cache, which was probably, yeah, when it was originally built, it was okay in theory, but the issue with putting things in the configuration in any kind of backend cache in Magento is our admin users. They make changes. They love to do whatever it takes to merchandise their products. They don't see a change on the storefront immediately, and the first thing that happens is they go into the admin panel. They find the cache, and they see that big orange button that says flush cache, and it gets clicked a lot. Thankfully, in 2.3, there's some ACL rules where we can limit who has access to do that. But most of our business users that are administering the storefronts on a day-to-day basis don't really understand, or they shouldn't have to understand, what the consequences are of cleaning the different cache types, and what changes that they make in the admin panel will require different types of cache clearing, or could require different types of cache clearing. So what happened next was really digging into what the interception cache was, and all it is it looks at every class inside of the object manager that's inside of the generated metadata already, and it just has a yes, no, or does this class have a plugin? So it's really just a Boolean with a class name. And it's all built from DI.XML. So once you deploy, it will not change until you have your next deployment. So writing it to Redis really didn't make sense because the data was actually immutable from the time that you deploy the application until the next deployment. So looking at what actually loads and going through the process, if you look at this snippet is after we had added some changes to correct this behavior or modify this behavior. So lines 64 through 66 didn't exist, and you can see it was just going back to the backend cache, grabbing the data, unserializing it, and returning it as the result of the cache. And at least locally, if you're tinkering with this, it takes about 30 milliseconds. That's 30 milliseconds on every single request. Now, if you're running a native storefront, that's not a whole lot, but it's a significant penalty on every request, and it's an even greater penalty as you look towards maybe a headless storefront where your request times are going to be, let's say, anywhere from 200 to 500 milliseconds. 30 milliseconds is a huge chunk of time. And this is running Redis locally, and in production, it's probably less than that in all reality, but we're still introducing some variables for network latency and load that really don't need to be there. So what was changed was instead of writing this data to the backend cache that setup DI compile was doing initially, is we match the behavior. I match the behavior of the other uh, components or the other steps of setup DI compile, and it writes the interception cache to the file system inside of generated metadata. And what this does is when you've compiled it, instead of going back to Redis, it can take advantage of opcache. This information is already it's already in memory. It's compiled down to bytecode. It loads almost instantaneous, and the result is, if you go back and you look at you profile again and you compiled the interception cache, there's the penalty to load it is so insignificant. Profiling tools such as Blackfire don't even capture it, because we're talking, it happens in nanoseconds instead of milliseconds. And so the future implication is there's a lot of what I would consider immutable data that gets stored in backend caches. And the reason for that is simple. It's really easy to look as we're developing and go, you generating this information takes a lot of time. It's CPU intensive, it's IO intensive. I'm going to generate it once and I'm going to cache it. And Magento makes that very easy, because Magento loves the backend cache and it loves Redis. And yeah, one of the places that this is very apparent is in the GraphQL project. And if you look at the internals of GraphQL, which, full disclosure, I've contributed my fair share of issues to this. So I'm hopefully not offending anyone, because I'm trying to criticizing work that I've actively been a part of. Is you have things like the stitch schema that we're putting inside of the configuration cache. Inside of the configuration cache, part of the reason it takes so long to regenerate after you flush it is it goes back to the file system. It looks at what's in env.php, it looks at what's in config.php, and then it looks at what's in the config.xml and every module that's loaded and registered inside the application. It grabs all that information and then calculates what the configuration actually, which one wins when it merges based on what's in the database as well, and the store scope and all that other stuff. But really, if we're running the application in production, none of that information ever changes. And our admin users can still change the information that's configured in the database, and that's fine. But in all reality, we should never have to go back to the file system to figure out what that base configuration for the code that's deployed on the server is. There's no reason. And we don't want to limit our admin users or our business users to not being able to change configurations on the fly. I mean, I personally, I don't want to be involved. I'd love to say we can just compile things like configuration during the build process and lock them, but I don't necessarily want to be involved, and I don't want developers to have to be involved if any of our business users want to change a configuration. And so that's where the future might lie for compiling things down and taking advantage of opcache. It's really more, can we take a look at what's inside of things like the configuration cache? Can we look and see what's in there? Look and see what wouldn't actually change when we're in production mode. Begin to optimize further. There's probably some opportunities to reduce things like cache stampedes as we're changing things on the fly, and clearing out the cache, especially when our servers be experiencing higher than normal traffic or high traffic or peak times. But that is it. So that's the path of how Magento leverages opcache for caching, the speed benefit of doing so if there is immutable data, and how we can potentially leverage that in the future as we continue to improve the performance of the platform that we're working with.
Thank you very much, Patrick. Really insightful talk. We have a few questions. The first one that I'd like to ask is, what would your advice be for anyone really wanting to get under the hood of Magento's cache systems? Like, where would you start? What should you start with?
I really enjoy, and it's gotten harder since for good reason. The data that's resting inside of Redis is currently encrypted, so it has been harder to look into it. But I do enjoy taking a look. And even just going through, browse what's inside of Redis. You can look at what the keys are. You can start to decipher how the keys are generated to see what data is stored. If you look inside of the framework and just set a breakpoint, you can really debug what's being loaded from the cache, and you can see how many requests go back out to the backend cache during a normal page load. I think last time I was looking at 2.4 develop, a simple PDP was about 124 requests to the backend cache to be able to render the page. So I really like browsing through what data is in there and seeing when it's loaded, and as well as kind of digging into, if you look inside of generated metadata, just look and see what's inside those files. They're not pretty, so if you're using an IDE, you can just use the auto linting to make it a little easier to read. But between those two, that gives you some insight into everything Magento's caching.
Yeah, that leads quite well on to the next question. What tools do you use for your performance profiling? What's sort of in your arsenal that allows you to sort of get this visibility that most people probably haven't looked at?
Blackfire. So I really enjoy using Blackfire. I'm not associated with them in any way, but there is a free tier that you can do profiling like this locally without having to pay for their service. It only keeps your traces, I believe, for 24 hours, but it's plenty of time to get some insight, make some changes, and just tinker to see what's actually happening under the hood. It's very similar to using cache grind and using the performance tracing that's inside of Xdebug. It's just a little easier to set up, in my opinion, and gives you some access to call graphs a little bit quicker.
Yeah, it's a really nice tool. We've used it quite a lot. Benjamin Volley has asked, what do you think of Magento Cloud's default configurations? Should they change something according to what you've just said?
I do not have a lot of personal experience on Magento Cloud, to be completely upfront. So I wouldn't be able to speak to that.
That's okay. What else have we got here? Do you have any top performance tips that you would recommend to every Magento developer?
Oh, watch Load in the Loop. So who is it? Ivan and
yeah,
Eric from Mage Mojo. Watch those YouTube videos or their podcasts. Great performance tips in there. Two incredibly intelligent members of our community who have a lot of experience optimizing sites and a lot of back history there, and they see a lot of really weird stuff and a lot of recurring issues. So watching it, keeping an ear out on programs like that is great, because especially for some of the module vendors, there's some recurring patterns there that you can pick up on as you tune into their podcast.
Yeah, I can only second that. Ivan seems to see the world in a very different way to most people, and it allows him to come up with some incredible solutions. Like the way he understands SQL is just a whole of a level to anyone else I know.
Absolutely, blows my mind. That the man is absolutely brilliant. I think that's the best performance tip. Just listen to whatever he says.
Another question. Do you think New Relic can be enough to optimize a website?
Oh, absolutely. Especially if there's budget constraints, New Relic is great. Even the free tier, you can get access to traces and you can see potential issues as users are going through and navigating the site in a way that you probably wouldn't be able to uncover initially with Blackfire. Because at least in my experience, New Relic is an excellent tool to identify issues, and then Blackfire is a good tool to dig in deeper to those issues as you're going through trying to fix whatever you uncover with New Relic, or whatever your preferred APM tool is on your servers.
Yeah, I find the slow transactions on there absolutely incredible to look at. But you can see some quite bad patterns used that you wouldn't necessarily see in a development environment, especially as the data in production can generally evolve far beyond what you would have on a development environment.
Yes, absolutely.
Right, I think that is all our questions. Thank you very much, Patrick. It's been a really insightful talk. It was great to have you on the digital stage. Not quite the mermaid, but it's allowed us to open up to such a wider audience. But thank you to everyone that's attended today. Our next talk is going to be at 2:30 with Chris Berenda from AbsoluteNet about building maintainable futures with Magento 2. So I will see you all there. And thank you again, Patrick.
Yeah, thanks, John. Thank you, everybody.